Hi guys, good morning. So we're going to start to discuss the second part of the second paper of the full paper series, right? So we have already discussed the MCQ part. Now you have to start from the another structured essay and then to the essay, right? Right. So shall we start? Give me a second. Right. So come to this part. Section A, structured essay. Shrimp, bees, fish, bird and animals are widely used for economic purposes, not only in our country but also in other countries. Name two organisms belonging to the arthropod family mentioned here. Now, what are the organisms mentioned under the arthropod family? One is a shrimp. What happened? One is a shrimp. The other one is the bee, right? So the shrimp and bee. Shrimp and bee, right? Shrimp and bee, right? So state a structure characteristic used to classify these bee as an invertebrate. Now, a characteristic of invertebrate. State the structural characteristic used to classify the bee. Yeah. So structural characteristic to classify a bee is basically um, having no vertebral column in uh, in at any point of their uh, life cycle, right? Having no vertebral column in any phase of their life cycle, right? Having no vertebral column in any phase of their uh, life cycle is the the simple definition that we can tell about the invertebrates, right? That is one of the main features. Name an organism from which pure chitin can be obtained from the laboratory use, that is shrimp, right? That's shrimp. Now these are easy. That is shrimp. The figure below shows of an external feature of a bony fish, right? State a major structural feature that distinguish this type of fish from cartilaginous fish, right? State a major structural feature that distinguish these type of fish from the cartilaginous fish. Now, one of the main features is gills are covered with a bony flap. That is this part. It's covered with a bony flap in the bony fish, and of the cartilaginous fish, it's just a few of the openings there, right? And about the tail, we call it the caudal fin. The caudal fin is symmetrical in the bony fish, and in the cartilaginous fish, if you remember the shark, it's asymmetrical, isn't it? Right. So you can write one of those, right? So gills are covered. Gills are covered with a bony flap. Gills are covered with a bony flap. Name the parts of the following letters before them. Right. So starting from the A, there is gills, isn't it? Or the bony flap covering the gills. That is gills, right? That is gills. B. Yeah, so the B is pectoral fin, right? That is pectoral fin. Pectoral fin. That is pectoral fin. Next is the C. C is the pelvic fin, right? C is the pelvic fin. Pelvic fin, right? The next one is the D. D is the lateral line, right? Lateral line. That's the lateral line. Next is the E. What's E? That's caudal fin. E is the caudal fin. That's the caudal fin. F. F. F is the dorsal fin. Dorsal fin. Dorsal fin. And G. What is G? Anal fin. Anal fin. Right. You should have labeled. Paper is in the car downstairs. Right. So these parts you should know to label, right? The next question, what is the most important function performed by section D? Yeah, the lateral line. So lateral line is sensitive for the pressure differences, right? To sense the pressure difference. Most important function performed by the section D, lateral, that is lateral line, and is responsible for the sensation of pressure difference. Pressure difference. Right. Sensation of pressure difference. Next one. Compose is made by accelerating the natural decomposition of organic matter through microbial activity. How is turning to compost fertilizer production a green process? Usually the green process means it's sustainable, isn't it? Green process means it's sustainable. That means like you produce it using sort of the materials, and once after you produce it, you can make the materials back again, and it goes on a cycle. So one of the materials will finish, and the other main thing is none of the products or the byproducts will get accumulated in the any of the spheres, isn't it? So like if it isn't you know, what do you call if it isn't recyclable or it isn't if it can't generate back again, it will get accumulated somewhere. That is the main issue. So that is why the greenhouse effect and everything are there. Things are getting accumulated because they are not recycling. So now the compost is a green process because it's made of the dead animal and the plant tissues, basically the plant tissues, and using these fertilizers back again, the plants and the animals are like produced. Can't say exactly the produce, like the plants are directly produced, but the animals are also indirectly feeding on it, so they are also produced back again, right? So it's a green process. So it's can be said it's a green process because it's sustainable, right? Process of making fertilizer using plant materials. Now the main thing is the plant materials, no? And the fertilizer is supporting the plant growth, right? Supporting the plant growth. Sustainable process of making fertilizers using plant materials, and the fertilizer is supporting the plant growth, isn't it? So it's recycling. That means it continues the cycle. So nothing will accumulate. That's the main thing. If something accumulates, that will cause a problem. Right. How does adding compost to the soil improve the quality of the soil when growing agricultural crops? Now, the main thing is that it makes the structure of the soil, isn't it? So basic structure of the soil is there because of the organic fertilizers, because the microbes producing these what do you call soil aggregates, right? And the soil aggregates make the aeration of the soil as well. So that is the structure of the soil. So they are making the structure of the soil one thing that the chemical fertilizers cannot do. How does adding compost to the soil improve the quality of the soil when growing agricultural crops? The main thing is making the structure of the soil. By soil aggregates. There is one thing. What is adding compost? They are asking only for one, right? लेकिन अभी एक कंटिन्यू कर लिया. And aerates the soil. So that the plant roots also can breathe. Right. Name two basic ingredients, materials required in the production of compost. Now, what are the main basic ingredients that should be there in organic production? Organic matter should be there. like the dead animal and plant tissues basically is the plant tissues. So the organic, natural organic matter. Or natural organic resources. What else? The other main thing is ඒකත් ගන්න පුළුවන්. Adding water. Right. Adding water to, that is because one of the hydrolysis process that occurs there with the microorganisms. So you're adding water, right? Water. Right. Fourth one, name 2 organic waste that are not suitable for compost production from household waste. 2 of the wastes that are not suitable. Something given in the note. Now first thing is to come with the something given in the note, and if there's nothing in the note, yeah, that's fine to answer something like that. So they were given some two things were given, I can remember. One is the urine. You don't put urine to the compost, because the urine will start, the anaerobic respiration, and the other thing is what? The coconut shells. Coconut shells are indegradable, right? So you don't put the coconut shells as well, because like the compost is made in like 3 months of time, so the coconut shell won't degrade in 3 months of time. So it's urine, could be cow urine, human urine, anything, you don't put it there. The other thing is the coconut shell. Coconut shell. State a reason why they are not suitable. Supports anaerobic respiration, supports anaerobic respiration. The other thing is indegradable. Or hard to degrade, right? Composting occurs through which main respiratory process? Those I see. Aerobic, yes. Aerobic respiration. Aerobic respiration. Right. Mention 2 optimal conditions used in the compost production. They were given 5, I think. Yes. So you have to come with the percentage. You have to remember those as well. And the temperature, and even the pH. I think it was the pH given. Yeah, the pH was in again 6 point something. I can't remember. So the temperature was 40 to 60 degrees of Celsius. Temperature. Should be around 40 to 60 degrees of Celsius. And humidity was also close, that I remember. That was 45 to 60 humidity. That was also close. Humidity. Was 45 to 60. And the pH was there, oxygen percentage was 5% or something, 5% of oxygen. 4 to 5 things were there. So if you can't remember, put a note that you should study the conditions. Right. What is the main method of compost production in urban areas? Bin method, isn't it? You're putting the bins, right? So yeah, bin method. Bin method. Right. Flowering plants in the plant kingdom are of 2 types, monocot and the dicot plants. The following figure shows the arrangement of a guard cell in the leaves of a plant. Indicate on the dotted line to which plant kingdom each belongs. Now this one is bean shaped guard cells. That is dicot. This is dumbbell shaped guard cells. This is monocot. Monocot plant. Right. Mention 2 other structural features that differentiate monocotyledons and dicotyledons. Mention 2 other structural features. Okay, the whole thing can take. The whole plant can take. Not like if it was given the leaves only. The leaves have like venation is venation are different. 2 type of venations are there. One is I had to tell specifically, I guess. Mention 2 other structural features that differentiate monocotyledons from dicotyledons. So you divide it. Monocot better this way. Monocot, then the dicot. And answer. So what is the venation? Yeah. Monocot venation is parallel venation. And the dicot? Network. What else? Yes. Fibrous root system. Taproot system. Name A and B in the diagram. A and B. What is A? A is the guard cell, isn't it? It's a guard cell. A is the guard cell. B is the stomata. Sorry. A එක මෙයානේ. B එක පෝ එක. So the A is guard cells. B is the stomata, isn't it? Stomata. What is the function of the part mentioned as B? What is the function of B? Yeah. Yes. And? Water එකකින් තමයි. Exchange of respiratory gases and water vapor. Right. State the main function of A. What does the A do? Yeah. Controls the transpiration, isn't it? Controls the transpiration by closing the stomata opening. By stomata opening. Mention two economic importance of plant leaves. What you can use the plant leaves for? For the medicines. Medicines extraction is one of the main things. And you can eat it, right? Food. Yes. A list of materials used in tissue culture technique is given below. Answer the questions asked in relation to it. What substance is used to sterilize the surface of small plant parts in tissue culture? E, right? Bleach and ethanol. Like they were given the specific detergents there. Twin 80 sort of like detergents were there. If you can't remember, like put a note to remember how to sterilize the surface of the plants. It was given like specific chemicals were given. Ethanol was there. I can't remember if the bleach was there, and this twin 80 or something was there. Sometimes the MCQs will come those are like hidden theories, but can come, right? Compound used as an energy source in the tissue culture. Yeah, sucrose, right? That is easy. Name the two growth hormones commonly used in tissue culture. They are asking for the names. I even told you the last time, I think, in the last paper, to remember the examples for the growth hormones. No, for the plant hormones. Examples for the 5 plant hormones are there, and for the auxin they have given the examples. So they are asking for those, I think. Name 2 growth hormones. Yes. No, right? No, they are asking for the growth hormones. Yes, auxin is the growth hormone. No, that is one of the essential oils. One of the essential oil components, geraniol. Name 2 growth hormones commonly used in tissue culture. This is confusing if it's asked for the cytokinin and auxin. But if it asks for the names, like the name wise, it's IBA, indole butyric acid, and IAA, indole acetic acid are the examples given. Name 2 growth hormones commonly used in tissue culture. Cytokinin and auxin can also take, right? හැබැයි අරකට මතක තියාගන්න මොකද auxins වල example can directly ask, like IBA and IAA, have to remember. So it's auxin and cytokinin. And remember the examples for the auxins as well. Vitamin that is often used as an antioxidant in the tissue culture. It's given here, is it? No, they're asking for the vitamin commonly used. What is the vitamin commonly used? C. Yeah, I think the C was there. Right, and it's an antioxidant as well. I think C is the only antioxidant, isn't it? All the others have like different functions. C is antioxidants anyways. What is the thickening agent used in the tissue culture? Ega. Yeah, C. Right. Solvent extraction technique is used to separate two immiscible solvents. The separating funnel used for this purpose and the way the solvents are separated are shown in the figure. If the proposed separation using the separating funnel is an aqueous solution of ether, right? What solution could be deposited in the lower layer of the separating funnel when placed stationary on the support? Does the question ask? The proposed separation using the separating funnel is an aqueous solution of ether, right? Now the aqueous solution of ether is there, so you have to separate ether from water. That is what you have to do. So you are adding one of the other solvents which is immiscible with the water but dissolves more ether in it, right? So what could be the deposit in the lower layer? So usually the one with low density is in the density. Density is the factor. Usually you know, the solvent that will be using in the solvent extraction method is volatile. Yes, it's more volatile because you are separating it from the water, then you escape the solvent and you take the residue of the ether. So for that it has to be volatile. So usually the volatiles are less. So in the bottom it should be water, isn't it? So it is, if it is water, so once the ether is extracted to the top layer, you remove the water from the bottom, then you remove the solvent. So it's water, isn't it? Should be water. State the reason for this conclusion.
Because water is more dense than the solvent.
Water is more dense than the volatile solvents. We'll tell it that way. Than the volatile solvent used, right? Than the volatile solvent used. Why is it advisable to mix this mixture gently before pouring into the separating funnel? Why do you mix? Now there's one good answer for that. Yes, no, that is correct, evenly distribution. But there's like one good phrase for that. What? Homogeneous? No. No. There are two phases there. When you are mixing two things that don't sometimes completely dissolve in each other, we call it distribute as two phases. One is which phase? Continuous phase and disperse phase. So now the main reason to do mixing is to, it was there in the industrial chemistry, I think. The main reason to mix is to have a uniform dispersed phase inside the continuous phase, right? To have a uniform dispersed phase in the continuous phase, right? That is the main reason. It was observed that several water droplets were mixed in the separated organic layer. In such case, name a compound that can be used to remove the water droplets from the mixture. So you have to add something chemical. Yeah, even copper sulfate is fine, but copper sulfate doesn't. Huh? No. අපිට dry copper sulfate දාන්න පුළුවන්, but copper sulfate doesn't absorb much. Something it was there in somewhere in the theory note. No, not silica. ඔය water අයින් කරන එකක් තිබ්බා. කොතනද තිබ්බේ? Potassium nitrate or something you are adding. Biodiesel production, I think it was there. අර මේවා ඩ්‍රයි කරනවනේ. බයෝඩීසල් එක ඩ්‍රයි කරනවනේ අන්තිමට. water molecules අයින් කරලා අන්න එතන තිබ්බා. Potassium nitrate. Yes, something. Potassium carbonate.
Calcium sulfate.
Yeah, the calcium sulfate. Calcium sulfate is used. So it was there in the biodiesel production.
And just magnesium sulfate.
Calcium sulfate was there. I can remember something like that. Calcium sulfate. CaSO4. Right. You can use thin layer chromatography in the laboratory to determine the purity of a secondary metabolite isolated by solvent extraction. The liquid chamber used for the TLC test and the thin layer chromatography plate prepared at the end of the test are shown below. Right. The thin layer is there and the chamber is also there. State the main substance used for the following zones in the TLC experiment. Mobile phase, the solvent, right? Which is the solvent is given here? Dichloromethane. That is the dichloromethane. Dichloromethane. Right. And the stationary phase of the TLC is what? That is the thing. We are like applying a mixture of something on the glass. Not Agar. It has a compound name. What do you apply there? It's silica gel. Can't remember if it is silica gel. I think it's silica gel. Or the silicon hydroxide or something. Sort of a silicon thing is applied on the glass plate. It's silica. Let's say a mixture of silicon hydroxide, I remember. Silicon hydroxide. You check that part. Make a check කරන්න. Chromatography එකේ ඇති. I think it's silicon hydroxide or something. Or mixture of silica. After adding the solvent mixture, the solvent chamber is closed and left for some time, and then the TLC plate is placed. State the reason for this. Why do you close the chamber? Hmm? You're adding a solvent, right? So the solvent has to saturate the chamber, otherwise any of the other gases will affect the process, isn't it? To saturate the chamber with solvent, right? So if you can't remember these, put a note. This is thin layer chromatography, preparation and the methods, results, everything. Mention 2 important points when drawing the AB baseline in TLC technique. So what do you do when you are drawing the baseline? This one. That's 1.5 or 1 centimeter. 1.5, right? Yeah. Solvent height 1 point. So yeah, that's 1.5 centimeters. Yeah, that is the main reason. When you drawing the AB baseline in the technique, yes. Draw the line. 1.5 centimeters. From the bottom. Yes. Use a pencil to draw the line. Which instrument used to place the sample on the TLC plate? Yeah, you can use a pipette, or if you don't have a pipette, a capillary tube can be used. A capillary tube or a pipette. Pipette or a capillary tube. What can you say about the purity of the sample is based on the results on the TLC? Yeah. Other than the pure compound, some of the impurities are there. Other than the pure compound, some of the impurities are there. Right. A vertical cross-section diagram of a distillation column used for the crude oil refining is shown below. The fraction leaving port 1 commonly contains compound X. The fraction leaving port 4 commonly contains compound Y. And the fraction leaving port 6 commonly contains compound Z. Okay. What is the primary source of energy contained in crude oil? Chemical energy, isn't it? So it's a chemical energy. Chemical energy. What is the common name for the group of organic compounds commonly found in crude oil? hydrocarbons. Name the crude oil refining method carried out in this tower. What is the crude oil refining method? Huh? Yeah, fractional distillation, yes. Fractional distillation. The boiling point of compounds XYZ are Tx, Ty and Tz respectively. Write them in ascending order. Tx, Ty, Tz. So now the temperature, what happens to the temperature going up?
boiling point
උඩට යන්න යන්න temperature අඩු වෙනවනේ. So the X has the lowest boiling point and the Z has the greatest. උඩ තියෙන X නේ. So X is the lowest boiling point. So X is the lowest. They are asking to boil the boiling points of a compound. Write them in ascending order. So the Ty is the Tz is the maximum, right? Oh, X Y X Y Z X Y Z. මේක T දාලා තියෙනකොට Tx Ty Tz boiling points කරන්නේ හරිය. The fraction leaving the opening mentioned in number 2 is rich in compound gasoline, petrol. These are widely used as fuel in vehicles. Write the balance equation for the combustion reaction of butane, C4H10, and abundant alkane contained in the gasoline. So C4H10 reacts with oxygen and the products that are carbon dioxide and water. And so what do you balance the first? Should be carbon. So 4 carbons are there. I'm going to add 4 carbons here. Now the carbon is balanced. Next, hydrogen. So the 10 of the hydrogens are there. You have to add 5 here. Now the hydrogens are also balanced. Finally oxygen has to balance. So now here it's 8 and 13 oxygen are there. Here it's only O2, so it's 13 over 2 you should put here, isn't it? It was like me multiply karna. So you can't keep a fraction there, so you have to multiply it by 2. So that will be 2C4H10 plus 13O2 8CO2 plus 10H2O. Right. This is the final one. This is the balance equation. Yes. Mention an environmental problem caused by gaseous components that may be released into the environment during the crude oil refining. The main one is the carbon dioxide, isn't it? And the sulfur is also there in the crude oil, so that's secondary. But mention an environmental problem caused by the gaseous component that may be released into the environment during the crude oil. The global warming, isn't it? So it's a global warming. And even if you consider the sulfur, you can write the acid rains as well. So it's global warming. This is the main thing anyways, because carbon is produced more. Sorry, carbon dioxide is produced more. The caloric value, energy generated during combustion of unit mass of fuel, of gasoline, which is commonly used as a fuel, is 4.7 into 10 to the power 7 joules per kilogram. Assume the density of the gasoline is to be 700 kilograms per cubic meter. Calculate the mass of the liter of petrol. So now per cubic meter it's 700 kilograms. Now how many liters are there in 1 cubic meter? Yeah, 1000 liters is cubic meter. Now if you are not sure, you have to convert it. So how do you convert it? You have to convert the cubic meters into cubic centimeters first, because we know 1000 cubic centimeters is 1 liter, right? So how do you convert the cubic meters into cubic centimeters? You have to multiply it by 100 3 times, isn't it? So that will be 10 to the power 6. That will be 10 to the power 6. Huh? 9. 100 times 3. So that will be 10 to the power 6. So there is cubic centimeters. Now 1000 of this is equal to 1 liter, right? So that will be how much? 1000 liters, right? 1000 liters. So now 700 kilograms are there in 1000 liters. So 1000 liters have 700 kilograms. You have to find per 1 liter, isn't it? So that is how much? 0.7 kilograms. 0.7 kilograms. Calculate the heat generated by 1 liter of petrol. So they are saying the energy generated during a combustion of a unit mass of fuel, that means per kilogram, right, of gasoline, which is commonly used as a fuel, is per kilogram it's 4.7. So you have to multiply, right? So 1 kilogram makes 4.7 to the power 10 to the power 7 joules. So you have to find how much would it make for 0.7 kilograms. So you have to multiply it by 0.7. 4.7 multiplied by 0.7. Tell it in powers. Ten to the power 5 or 3.29 into 10 to the power 7 joules, right? A liter of petrol is required to travel 12 kilometers at a certain uniform speed. Assume the efficiency of its engine to be 80%, right? That means 20% is what? 80% is efficiency. That means the effective work over the input, right? So input is 100%, 80% is effective, the 20% is usually it's heat, right? So calculate the assume the efficiency of its energy to be 80%. Calculate the thermal energy required to travel the distance of 60 kilometers at the same speed as below. Now a liter of petrol is required to travel 12 kilometers, right? And the efficiency is 80%. Calculate the thermal energy required to travel 60 kilometers. Now they are asking for how much of the thermal energy is produced traveling 60 kilometers basically, right? Oh, now they say the liter වලට 12 kilometer එතකොට 60 වලට 5 liters යනවා. 1 liter වලින් මෙච්චර energy ගන්න 80% එක. ඒ කියන්නේ 100% ඒ කියන්නේ petrol වල energy එකෙන් petrol gives 100% of energy. Out of that energy 20% is heat, 80% is effective use for the transportation. So they are asking for the heat produced when traveling a 60 kilometers, that's all. So you have to use 5 liters, that is the first thing. So 5 liters make a energy of this into 5, and 20% of it is the heat, right? So you have to multiply 4.7 to the power 10 to the power 7 and multiplied by 5, because 5 liters takes a 5 liters takes for the complete 60 kilometers of a run, and 20% of it, right, is the heat. So this should be the answer, right? How much? Telling powers, huh? Now this cancels out, isn't it? This is 5, 5 cancels out. It's the same answer. 4.7 into 10 to the power 7 joules is produced as heat. Calculate the amount of work done by the engine for this. That is the 80%, isn't it? So you have to calculate the 80% of this. You have to calculate the 80% of this. So that will be 4.7 10 to the power 7 into 5 into 80%. One hundred and 10 to the power 6. 1.88 into 10 to the power 8 joules. Okay, decimal එකකට දැම්මම හරි. If the car overcomes a constant friction, give me a second. එකපාරක් කට් කරාම ආපහු ගන්නවා. හදිසියක් දන්නේ නැහැ මේක ආන්සර් කරේ. මැරෙන්න ඉන්නවද දන්නේ නැහැ. නැත්නම් දැනගන්න ඕන කට් කරාම පස්සේ බිසි නම් ආයි ගන්න නැතුව ඉන්න. පොඩි දේවල් වලට ගන්න. If the car overcomes a constant friction force of 900 between its tires and the road, find the distance it can travel on 1 liter of petrol. Now come up with an idea, how do you apply? F into D. Work done against the friction, and you have to equal it to something. F into D is equal to what? Yeah, work done against the friction is equal to, we don't have any mu or mg or anything. That is work done against the friction converts into what? Work done against the friction is converted into No, yeah. Now, when do you do the work against the friction? No. Yeah, working against the friction usually when you are slowing down or braking, isn't it? So the work done against the friction is usually converted into what? Isn't it? It's the heat, right? So the work done against the friction is this, like in any of the case, is converted into heat. Oh. හැබැයි මේක කියන්නේ car overcomes a constant frictional force of 900 newtons between its tires and the road. Find the distance it can travel on 1 liter of petrol. So the 1 liter of energy වලින් තමයි ගන්න ඕනේ. ඒතකොට heat එක වෙන්නේ කොච්චරද? 20% of that. So F into D, 900 into D should equal to 4.7 into 10 to the power 7 and 20% of it, isn't it? Because the 20% is converted into heat. So you can find the D. $10,444 44.44 joules. So the meters, right? Meters. Right. The capacity of a car's full tank is 45 liters. It is filled with petrol at 10 degrees of Celsius. From that moment on, the car is parked at a sunny place where the temperature is 35 degrees of Celsius. Calculate how much fuel will spill due to the expansion of the fuel. Ignore the expansion of the tank. 1 liter equals 1000 cubic centimeters. The coefficient of the volumetric expansion of the petrol is 9.6 into 10 to the power minus 4. So which formula should you put? Is it delta V or the V1?
Delta V equals V1.
It should be delta V because they are asking about how much has spilled, right? So the how much has excessively expanded, that's the delta V. What happened? Accidentally erased the whole thing? Did I? I think. Right. Should be delta L equals, delta V. Delta V equals V naught gamma delta theta, right? So you have to apply the values. V naught, it says 45 liters. Now, that is a thing. You can't put it in liters. You have to convert it into cubic meters. Yeah. Better you apply in cubic meters. Now, if you apply this in, even that is fine, because if you apply this in liters, this will come in liters, because now this doesn't contain any of the liters or meters or cubics and nothing. So only if you apply this in liters, this will give liters. So that's okay to apply in liters. Yeah, fine. So 45 liters. Now that is only if the coefficient isn't in the the cubic meters or something, right? this doesn't contain the volume dimension, it's nothing to worry about, because this to this will cancel out. So whatsoever the unit you put here will give the delta V. 45 liters into 9.6 into 10 to the power minus 4, right? And the delta theta is 35 minus 10. 35 minus 10, that is 25. Expansion will be in liters. Huh? How much? 46.08 liters. Right. Okay. Oh, delta V. මේක දෙන්නේ ආන්සර් හරියට. එහෙනම් ඩබල් වෙලා එක්ස්පැන්ෂන් එක. හැබැයි එච්චර ඉන්න බෑ, මේක -4 තියෙන්නේ හරි. +4 නෙමෙයි. -45 into 25 බලන්නකෝ. කොතනද? නෑ ඒක නෙමෙයි නේද? delta v නේ. delta v equals v naught gamma delta theta. So complete multiplication there. Did you put the v1? So that is 1 point something. The answer is 1.08. You have applied the other one, right? Make a spill which amount again. So the delta should be the equation. Expand which complete amount again v1. So it's 1.8 liters, right? 1.08 liters. See, the mass of this car travels at a speed of 90 kilometers per hour is 1200 kilograms. The car is stopped suddenly using brakes. If the mass of a brake pad is 8 kilograms and the specific heat capacity of the material is made of is 600 joules per kilogram per Kelvin, and 50% of the total energy produced during stopping the car is divided equally among the 4 brakes. Find the amount by which the temperature of the one of the wheel rises. That's a bit of a good question. Now the mass of the car is traveling at a speed of 90 kilometers per hour, and the weight is given. So when the car is stopping, that energy is 50% of the total energy produced during the stopping is divided. Now the car is traveling in this speed with this weight, and the energy there when it is stopping, the 50% of that energy is given back to the brake pads, and it's divided equally, and they're asking for the amount of heat. So you have to find the energy first. How do you find the energy? What is the energy there of the car? Velocity and the mass are given. What is the energy? Huh? The kinetic energy, isn't it? So you have to convert 90 kilometers per hour into meters per second first. So that is 90 into 1000 divided by 3600. Now divide this. 9 times 1836. 9 times 4. 100 divided by 4 is 20. 5 ms minus 1 is it? 25 ms minus 1, right? So the energy EK will be mv square, half mv square, half into 1200 into 25 its square. That will be 600 into 25 square is 500 and 625. Complete answer is
Answer is 375,000.
375,000 joules. Right? So that is the energy, and half of it, 50% is the half of it, no? Is given to the brake pads. Find the amount of which the temperature of one of the wheel rises. Oh, මේක 4ෙන් බෙදන්න ඕන. මේක 50% ආපහු 4ෙන් බෙදන්න ඕන. මේක half අරගෙන ඒක ආපහු බෙදන්න ඕන. එතකොට brake pad එකේ mass එක දීලා තියෙනවා නේ 8 kilogram. එතකොට එනවා amount of මේක අපි කෙලින්ම apply කරමුනේ නැත්තම් මේක දාන්න ඉඩමදි. අපි කෙලින්ම apply කරලා දාමු. එතකොට මේකෙන් අපි powers වලින් ගමු. එතකොට ඉඩ තියෙනවානේ 3.75 into 1 2 3 4 5 10 to the power 5 and half of it and again quarter of it is equal to mc theta. M is 8 kilograms, C is 600. Initial temperature isn't given, right? So they are asking for the delta theta directly. So simplify this, you get the answer. Nineteen point 52 degrees of Celsius. That's a good question though. Right. Next thing. The figure below shows the equilibrium position of a light rod carrying an object X and a mass M. M mass is 300. M is 300. Of the two suspended masses, which one has the greatest mass? Objects X or the object M? The one with the shorter distance has to have the greater mass, right? So it should be M. State the reason for the conclusion. That is the reason. One with the shorter distance has to have the greater mass to even the torques, right? To balance the torques. Mass with the shorter distance has to have the greater mass to balance the torque. If OA equals 40 centimeters and OB equals 20 centimeters, OA 40 and the OB 20, derive an expression for the equilibrium of the rod using the moment of force. That will be 40 into x equals 20 into m. Obtain that x over m equals half. You just simplify this, right? So 40 into x equals 20 into m. So x over m, right? So the x over m equals 20 over 40 equals half. When the object X in above equilibrium system is completely immersed in a container of water, the equilibrium position of the system is shown below. Density of the water is 1000 kilograms per cubic meter. Right? Explain the reason why the equilibrium point is moved 5 centimeters from O towards B. Now it has moved little bit towards the B, shortening the length of M, Y.
Downward force acting on X is
Mhm.
because there's an upthrust.
Yeah, the downward force acting on the X is reduced due to the upthrust, and the torque is reduced, right? Therefore, to even out the torque, the reduced torque from the M mass, the length should be reduced, right? So the abhi ka simple लियम नहीं, torque is reduced in X side due to upthrust. To even the reduced torque, length of the B side should be reduced, isn't it? Should be reduced. Calculate the length of OA. Now the earlier it was 40 and 20. Now it should be 5 centimeters shifted this way, that is, this is 15 and this is 45. So the OA is 45, isn't it? Yeah. Calculate the weight of X in water. Now that will be X into 45 equals M is 300 grams. 300 grams into 15. So 15 times 3, that is 100, right? 100 grams. Or you can put it in newtons because it has asked for the weight, not the mass. Right? So divide by 1000, multiplied by 10. There is 1 Newton, right? Yeah, right. 1000, 10. Ah, yeah, 0.1 newtons. Sure. Accordingly, what is the weight of the X in the air?
45, 10
what is the weight of the X in the air කිව්වහම පස්සේ මේක ගන්න බෑ. පරණ length එකකින් ගන්න ඕන. එතකොට ගන්න ඕන X into 40 equals 300 into 20 නේ. 20 නේ තිබ්බේ. That is 150 grams. 1.5 newtons. Calculate the density of the object X. Now you have the weight and what is the volume given? No, you have to calculate the volume. How? Do you understand the question? Because the density of the water is given, wasn't it? Here. So you have to equal it to the upthrust. Now you know the weight of the object. Now how much is the upthrust? Now this is when the upthrust is acting 100. This is in air. So the upthrust is
0.15
make it? Sorry. Yeah, right. 0.5 newtons. So 0.0 මුලින් අපි volume එක හොයාගන්න ඕන. 0.05 newtons is equal to V rho g, isn't it? Is equal to V rho g. Rho is 1000. G is 10. And the V is how much? 5 into 4 of the zeros are there. 1, 2, 10 to the power minus 6 cubic meters. 5 into 10 to the power 6 cubic meters. And you have the weights. D equals M over V. You know the mass 150 grams. So it's divided by 1000, that is 0.15, right? 0.15 kilograms. Divide by 5 into 10 to the power minus 6 cubic meters. This should be the answer. How much? 30,000. Kilogram per cubic meter. Right. A child states that after X is immersed in the water in the container, the position of the mass B can be changed to balance the system. If so, state the position where the mass B should be reattached. So if you are changing the mass, so now the weight is 100 grams, isn't it? Because the upthrust, and the length of X was 40. Yes, and now you have to change the place of the mass. So no. Right, so you have to change the place of the mass, that is the distance. So equals, the mass was 300 grams, we'll take the distance as L. So you simplify this, you get the length, that is 3. So L equals 40 over 3 is how much? 13.33 centimeters. If X is immersed in a coconut oil solution, the support must be moved a shorter distance than before to reach the equilibrium point. Explain the reason for this. So because if you are using the coconut oil, the upthrust will be less than the water, because the coconut oil usually have like 800 something. Yeah, 800 kilograms per cubic meter, and the water is 1000. So because the upthrust is less, the torque will be reducing less. Therefore, it has to move only a short distance to come to the equilibrium back again. Right. Yeah, so that's it, the structured essay part. We'll do this another time, right? Yep. It will be good if Ravish can also come in the morning. because the paper discussion is important, isn't it?
One line.
You haven't made it,